Assalamu alaikum students. Today's our lecture is going to be about numericals of rotational and circular motion. Let us read the first numerical. If a plate microwave oven has a radius of 0.5 meters and rotates 6 revolutions per minute, calculate the total distance traveled by the fly or the wheel on inside the microwave during the 2 minutes cooking period. Now here we have the microwave. Inside the microwave is a plate, and that plate is revolving. Let's say it is revolving this way, and it is of the radius 0.15 meters, and the revolution per minute is 6 revolution per minute. Now he says during the time, let's say 2 minutes, which is over here, how much it has covered its distance, which is here. So let us calculate the distance for this one. Solution, we have the data with us, which is the radius 0.5 meters, rotation per minute is 6 revolution per minute. We have to convert this revolution per minute into radian per second. So revolution per minute. So how many revolutions are there? So if a body completes one whole revolution, that means it has covered a distance of 2 pi in radian. Divided by minutes can be converted into seconds. So 1 minute has 60 seconds. So that is how we can convert the revolution into radian per second. So total distance traveled we have to calculate, which is question mark, and the time given to us is 2 minutes, and we can convert that 2 minutes into 120 seconds. The angular velocity, which is given in radian per second, which will be 6 multiplied by 2 pi by 60, because we have to convert the revolution into radian per second. So the answer will be 0.628 radian per second. Formula. First of all, we use the formula of angular displacement, which is equal to theta is equal to omega t, which omega is the angular velocity and t is the time or instantaneous time taken. So angular velocity we have already calculated, which is 0.628, which we put over here, and the time is already given to us, which is 120 seconds. Putting in the values in the formula, we'll find the value of theta, which will be equal to 75.36 radian. Now, how can we find out the distance in this case? We have a formula S equal to r theta. We have the value of r. Now we have the value of theta. We put in the values of both of these and we find out the value of S. As we know, S is equal to r theta. Putting in the value of r, which is 0.15, and the value of theta is equal to 75.36 radian per second, we find the value of distance, which is 11.3 approximately, or 11 to be exact in this case. Moving on to the next question, a circular drum of radius 40 centimeter is initially rotating at 400 revolution per minute. That means there is a drum over here, just like this, and it is rotating, and it has a radius of 40 centimeter, and it is rotating at 400 revolution per minute, making 50 revolution. That means how many turns it has made? It has made theta is equal to 50 revolution. Now, what is the angular acceleration? We have to find the value of alpha, and stopping time, and we have to find the value of time, how much time it took to stop this rolling drum. Now in this case, we have the solution and the data is given to us. The radius is 40 centimeter, we can convert it into meters for SI units. The angular velocity, which is initial velocity, or in angular form, which is 400 revolution per minute, which is 400 into 2 pi divided by 60, because we have to convert that into a radian per second. So when we multiply 400 by 2 pi divided by 60, we'll get 41.9 radian per second. The angular displacement was given to us as 50 revolution, so we can convert the revolution into radian by multiplying it by 2 pi, which is 314 radian. Now in the next case, we have a final angular velocity which is equal to omega f, which is 0 radian per second. Why? Because in the question, it is brought to stop. So that is why the final angular velocity is 0. The angular acceleration is alpha. We can say the rate of change of angular velocity per unit time, or sorry, the rate of change of angular velocity is known as angular acceleration. Now the stopping time is given, and we have to find that time, that how much time it took for it to stop. Let us find the formula. In this case, the formula we are using actually is third equation of motion, which says 2 theta alpha is equal to omega f square minus omega I square. Now in this case, we have third equation of motion, and we have the formula as well over here. So if we can find out the values from here, we get alpha will be equal to omega f square minus omega I square divided by 2 theta. We get, we put squares over here, omega square, omega f square, omega I square. Putting in the values, and we get 0 f square, 0 square, because f has the value of 0. Find the velocity, and initial omega square has a value of 41.9. Putting that value, dividing it by 2 theta, the value of theta we have already calculated, which is 314, multiplied by 2, and this will be equal to angular acceleration, which is equal to alpha. Now if we continue, alpha will be equal to minus 2.79 radian per second. What does the minus sign signifies over here? That means it is decreasing as the uh, drum is rotating. It is basically decreasing in speed. That is why the negative sign is there. Now for the stopping time, for that we are using this formula. Alpha is equal to omega f minus omega I divided by t. For time, we have alpha is equal to omega f minus omega I divided by t. So we have to find the value of t, taking t to the other side and taking alpha in the denominator of cross multiplication. We get t is equal to omega f minus omega I divided by a. It will be 0 minus 41.9 divided by minus 2.79. So this minus sign, because we know 0 minus 49.9 divided by minus 2.79, so it will be 41.9 minus 2.79. So this minus minus cancels out, because both of them are noted for time, and time is negative. So the answer is 15.01 second, or to simplify it, we can say it is 15 seconds to be exact. Next question is, a string is 1 meter long, whirled at a 100-gram stone in a horizontal circle at a speed of 2 meters per second. Find the tension in the string. Now there's a horizontal circle like this, and a string is basically whirled around it. Now how much the tension is in the string? That is the question. Now for that part, we have to calculate, because it is moving in circular motion. We have to keep in mind that a force which keeps a body in circular motion is the centripetal force, which has a formula Fc is equal to mv square over r, where r is the radius. Now let us apply the data over here. The length of the string is r, or length you can say is 1 meter. The mass of the stone is 100 grams or 0.1 kilogram. The tension in the string is T. We have to find that out. Here the tension in the string must be equal to the centripetal force, C. In this case, we have to find the centripetal force, which will be equal to the tension in the string. Now let us put the values. The tension in the string, which will be equal to the centripetal force, which has the values mv square over r. Putting the values of m, which is equal to 0.1. Putting value of v, which is equal to 2 meter per second. And taking square, the r value has 1 meter. So by putting in the values, we can find out the value of t, which is equal to 0.4 newtons, and that is our answer as well. Moving on to the next question. A moon revolves around the earth in most circle of radius 382,400 kilometer in 27.3 days. What is the centripetal acceleration? Now, this is our earth like this, and moon is basically revolving around the earth, and it takes 27.3 days to basically circle around the earth, and its centripetal acceleration has to be found out, and the radius of this circle from here to here is given by r, and which is equal to 382,400 kilometer, or you can say 382,400 into 10 to the power 3 to write down in scientific and in SI units. So here we have the solution. The data is given to us. The radius of the circle is 382,400 into 10 to the power 3 meters. The time period is given to us. We have to convert the days into, first of all, hours, then into minutes and seconds. We have 2358720 seconds. Centripetal acceleration has to be found out in this case. We know that AC is equal to V square over R. Converting the V into angular form, R square divided by omega square divided by R, it will be equal to R omega square. Now what is done over here? AC is equal to V square over R, we know that. AC is equal to V, we can say it as R omega instead of writing like that. So instead of V, what we can write down over here, instead of V, we can write down AC is equal to R omega whole square divided by R. So if we take square of both of these values, then this R and this R square will be cut. AC will be equal to R omega square, and that is why I've written R omega square over here. AC is equal to R into 2 pi over T, because it takes a whole round trip. The circumference is 2 pi, and time period is given is of 27.3 days to rotate and cover the orbit around the earth. That is why 2 pi is given, and omega is equal to 2 pi over T. So how is it possible that omega is equal to 2 pi over T? Actually, it is omega is equal to theta over T, angular displacement over T. How much is the angular displacement? That is the total circular motion. That is why the value of theta is given to us 2 pi, and the value of T is given as well. Now, if we put in the values, we get AC is equal to 4, because this 4 comes over here. The value of pi square is given to us. The radius is given to us. The time period is given to us as well. So taking square of the time period, putting in the values, what we get? We get the acceleration equal to 0.0271 meter per second square, which is the centripetal acceleration for the moon to orbit around the earth. Question number 5 says a modern F1 car can accelerate from 0 to 62 miles per hour or 100 kilometer per hour in 2.5 seconds. What is the angular acceleration for its 170 millimeter radius of wheel? Now, if we want to draw a racing car like this, and it has tires like this, and the tires width is, you can say, is 170 millimeter. So what they are asking, they want to find out the angular acceleration alpha in this case, and when the car is moving with an acceleration of, let's say, we have to find the acceleration in this case as well. The final velocity in this case is given to us, Vf is given to us is 100 kilometer per hour, and it started from basically rest from here and moved from here to here, sorry. So over here its velocity was 0 meter per second. Why? Because it started from rest. So 0 meter per second the car moves, and what will be its angular acceleration? Let's find it out. The initial velocity given to us is 0 kilometer per hour. The final velocity is given to us, which which is 62 miles per hour or 100 kilometer per hour, or we can convert it into meter per second by multiplying by 1000 and divided by 3600, we'll get 27.77 meter per second, and that is our answer for final velocity. Moving on, we have the time 2.5 second. We have the radius 170 millimeters, or we can say 170 into 10 to the power minus 3 meter. We have to find the acceleration as well as angular acceleration in this case. First of all, let us find the acceleration. Acceleration has a formula: rate of change of velocity Vf minus Vi divided by t. Putting in the values, it will be 27.77 minus 0 divided by 2.5. The acceleration given to us is 11.1 meter per second squared. But that is the acceleration, not the angular acceleration. We have to find the angular acceleration. The formula for angular acceleration is A is equal to R alpha. Now, in this case, alpha can be found out by A divided by R. So we have the value of R over here, and we have the value of A over here. We divide by R by A. What do we get? We get the value of angular acceleration. So A is equal to R alpha. From that, we found out the value of alpha is equal to A over R, which is equal to 11.1 divided by 7, 170 into 10 to the power minus 3. The value of alpha will be given by 65.29 radian per second. That is the right answer. So here, don't be confused that this is alpha over here. Moving on to the next question. It says an electric motor is running at 1800 revolutions per minute. It comes to rest in 20 seconds. The angular acceleration in uniform. Find the number of revolutions made before stopping. Let's say that this is the motor. Let's say it is moving. There's a motor over here. It's rotating this, let's say any part of it which is rotating, and it is rotating 1800 revolution per minute, and it comes to rest. That means the final angular velocity is equal to 0, and the acceleration is uniform. That means it decreases quite nicely uniformly before coming to stop. That means it has stopped. The final velocity is 0. Now, in this case, we have the solution. The initial angular speed is given to us, which is 1800 revolution per minute. We have first of all convert the revolution per minute into radian per second. So we multiply by 2 pi and divide it by 60, because revolution has to be converted into radian and minutes has to be converted into second. So when we multiply 2 pi by 60 by 1800, it will be 188.4 radian, and that is our answer, 188.4 radian. Find the angular speed. We have the final angular speed, which is equal to 0, because it has stopped, it has come to rest. Now, the time taken for it to stop is 20 seconds, which is given in the data. Number of revolutions, we have to calculate how many revolutions are there, and we have the number of revolutions is equal to total angular displacement by 2 pi. That means how much revolution per whole rotation. Now, n is equal to theta by 2 pi. This is the formula. We now have alpha is equal to omega f minus omega I divided by t. This is the first equation of motion with respect to angular form. Theta is equal to omega I into t plus half alpha t square. Putting in the values, we get theta is equal to omega I plus into t plus half. Instead of alpha, we are writing down omega f minus omega I divided by t into t square. This t and this t cancels out. So what we are left with? We are left with omega theta is equal to omega I into t plus half omega f minus omega I into t. This is the new formula which we have made from second and first equation of motion in angular form. So putting in the values, what do we get of value of theta? It will be 188.4 into 20, which is the time, half into 0, which is the final velocity, angular velocity, minus initial velocity is 188.4, multiplied by the value of t is 20. So after putting this value, what do we get? we get 188.4 into 20 plus 1 over 2 minus 188.4 into 20, we get 3768 minus 1884. The rotation we have is 1884 radian. That is the rotation of that motor in just 20 seconds. Putting the value of theta in equation 1. Now in this case, the number of rotation, how many rotation were there going to be in 20 seconds? Let us put the values, and number of rotation can be found out by dividing it by 2 pi. So n, the number of rotation will be given to us will be 188.4, 88.4 or 84 radian divided by 2 pi. So we can convert from radian into numbers. So it will be 300 revolution. That means after 300 revolution, the motor has stopped in just 20 seconds. What is the moment of inertia of 100 kilogram sphere whose radius is 50 centimeter? Now we have a sphere. Sphere is that substance which is you can say three-dimensional form of a ball or circle, a three-dimensional form, just like a bowling ball, you can say, a spherical bowling ball. Now it is of 100 kilograms, let's say it is of 100 kilograms, and it has a radius of 50 centimeters. Now in this case, let us find the moment of inertia. The mass of the sphere is 100 kilograms. First of all, we have the mass, and the second we have the radius, which is 50 centimeter. We can convert that into meters by dividing by 100. So it will be 0.5 meters. The moment of inertia is I, and moment of inertia is given by mr square. And moment of inertia for sphere is actually different, not this one. Actually, the moment of inertia for sphere is 2 over 5 mr square. So we know that the moment of inertia of a solid sphere is given by I is equal to 2 over 5 mr square. Putting in the values, 2 over 5 into 100, which is the mass, and 0.5, which is the radius, whole square, we get the value is of I, which is the moment of inertia, which is equal to 10 kilogram meter square. And that is our answer. The next question says, question 8, a rope is wrapped several times around a cylinder of radius 2 meters. Let's say this is our cylinder, and a rope is wound around it, which has a radius from here to here is of 2 meters. The mass of this cylinder is 30 kilograms. What is the angular acceleration? What is the angular acceleration? In this case, we have to find alpha. And if the tension in the rope is 40 newtons and it turns without friction, we have to find the tension, that if this rope is being wound and being pushed, then how much is the tension in this rope? Let us find the values. The data is given to us. R is equal to 0.2 meters. Mass is given to us 30 kilograms. Friction is given to us is 40, and we have to find the value. Sorry, not friction, force is given to us, which is 40 newtons, and alpha angular acceleration is given to us as well. We have to find the value of angular acceleration. We have the formula T is equal to I alpha. This is not actually the T, this is torque. Torque is equal to moment of inertia into angular acceleration. Now, we know that torque is a turning effect produced by a force. We know the formula. Now, we are going to use it. So, instead of torque, I'm going to write down the moment of F into R, and moment of inertia of a cylinder is given to us, which is half mr square, and alpha will be written as is. Now, in this case, alpha will be given out, or will be figured out, then 2, let's process it out. Fr is equal to half mr square alpha. This 2 goes over there, it will be 2. Fr is equal to mr square alpha. 1 r cancel with here, so it will be 2f is equal to mr alpha. This both mr goes to the side, it will divide, so alpha will be equal to 2f divided by mr, and this is how we got this answer. So putting in the values, 2 into 40 divided by 30 into 0.2, where 0.2 is the radius given to us, and mass, which is 30 kilogram, is also given to us. So the answer is 13.3 radian per second square, and that is our answer as well. Moving on to the next question, what is the kinetic energy of a 5.0 kilogram solid ball whose diameter is 15 meters if it rolls across a surface with a speed of 2 meter per second? Now we have to find out that a ball, let's say a ball is there who has a radius of 15 meters, and it has a weight of 5 kilograms, and is rolls across a surface with a speed, let's say a speed of 2 meter per second. Now in this case, we have a body which is rolling on a surface. In this case, not under the direction of gravity, we can say it like this, that if this is the ball and this is the surface and the mass is acting in downward direction 5 kilograms, so let's just write it down. Like in this case, this is the ball and the ball is moving with a speed of 2 meter per second. The mass is acting in downward direction 5 kilograms, and whose diameter from here to here is, let's say, 15 meters. So we have to find its kinetic energy. We already have the velocity and we have the mass, and kinetic energy is given by half mv square. Now let us see that how can we find out the values of this kinetic energy. So the diameter is given to us, which is 15 centimeters. So actually it is not 15 meters, this is 15 centimeters, and 0.15 meters, that is the right answer. So 15 meters is the right answer. Moving on to the next part, radius of the solid ball will be divided this diameter by 2, we get 0.5 divided by 2, it will be 0.075 meters. The speed of the ball will be given to us, which is 2 meter per second. To find the kinetic energy of the rolling ball, which is Ke, and we know that the rolling ball possesses both rotational kinetic energy as well as translational kinetic energy, which is given by rotational kinetic energy plus translational kinetic energy will be equal to total kinetic energy. That means rotational plus linear will give us the total kinetic energy in this case. Now the total kinetic energy will be equal to half mv square, which this is for the linear part, and half omega square I, or I omega square, which is a rotational kinetic energy. Putting in the values of for a solid sphere, we have to know the moment of inertia. I is equal to 2 over 5 mr square. So I is equal to 2 over 5 mr square. Putting in the values in the above equation, and we are replacing omega r by v, because we know that v is equal to omega r, so omega will be equal to v over r. Putting the values of equation number 2, this one, and equation number 3, this one, in equation number 1, in this equation of omega and I in equation number 1, we get kinetic energy equal to half mv square plus half into 2 over 5, which is the moment of inertia of a sphere, multiplied by v square over r, which is the angular velocity form of linear velocity form of the omega. Omega will be equal to v square over r square, so that is where it came from. So kinetic energy will be equal to half mv square plus 1 over 5 mv square. Now in this case, we have the procedure with us now. So kinetic energy will be equal to half into 5, which is the mass, multiplied by velocity, which is 2 square, plus 1 over 5 into mass, which is 5, and the velocity is 2 square. Now if we solve it, we'll get the value of this one equal to 10, and the value of this one, because this cancels out, it will be equal to 4. So 10 plus 4 will be equal to 14 joule, and that is our required answer as well. That means when a body is moving with a radius of, let's say, 0.15 meter and has a weight of 5 kilograms and moving with a speed of 2 meter per second, then kinetic energy it possesses both cause of rotation as well as translation is going to be 14 joule, and that is our answer as well. Question number 10 says a cylinder of a 50 centimeter diameter at top of an incline 29.7 centimeter high and 10 centimeter long is released and rolls down the incline. Now here we have the incline, show like this, and here's a cylinder like this. The height of the incline is from here to here, it is 29.4 centimeter like this, and the length which it has is 10 meters long. Now as it is rolling down, we have to know the moment of inertia of this cylinder, and we have to know the angular speed of this cylinder, and neglecting all friction, find its linear and angular speed. That means we have to find the value of v as well as we have to find the value of omega as well as it moves down. Now in this case we have the formula, the diameter of the cylinder which is 50 centimeter of 0.5 meters, actually because we are dividing it by 100, so 50 divided by 100, it is going to be 0.5 meters. So the radius of this cylinder is dividing the 50 or 0.5 by 2, we'll get 0.25. Yes, now it is correct now. So it is 0.25 radius. The height which is given to us, which is 29.4 centimeter, or we can say we can convert it by dividing it by 100, so it will be 0.294 meters. We have to find the linear velocity and the angular velocity over here. The solution is given to us. Part A, the linear velocity can be found out by v is equal to under root 4 over 3 gh. We have the formula of this cylinder. So putting the values of 4 over 3 and the value of g is 9.8 and the value of h is 0.294, and that's it. This 4 over 3 is written as it is. So when we divide it, what do we get? We get velocity is equal to 1.96 meter per second, and that is the answer. We have to only take this part 4 over 3 into 9.8 into 0.294, which is the height. If we want to find out the omega part, we have to multiply omega with r, or if we want to find out the value of omega, we can divide the value of v by r. So we are dividing the value of v by r, which is equal to 1.96 divided by value of r, which is equal to 0.25. The value of omega will be equal to 7.84 radian per second, and that is our second answer as well. So 1.96 is for the velocity, and 7.84 radian per second is for the angular part. Moving on to the next question, question number 11. A disc without slipping rolls down a hill of a vertical height 1000 centimeter. Now here is our situation. Here is a disc. Let's draw a disc. It is rolling down a height of, let's say, 1000 centimeter. This starts from rest, that means it starts from rest, that means initial velocity is equal to 0 meter per second from the top of the hill, right over here, top. What is the magnitude of the velocity at the bottom? We have to find the final velocity in this case. So how can we solve this now? In this case, we have the data. The height of the hill is 1000 centimeter. So we can convert that centimeter into meters. So we have to divide it by 100. It will be 10 meters, that means 10 meters. So height is 10 meters, that is correct. Now to find, we have the speed at the bottom, that means the final velocity at the bottom part. So we have the velocity for a disc or a cylinder, you can say, which is equal to V is equal to under 4 over 3 GH. Where did we get this formula? We have derived it from this rolling down inclined plane, or cylinder rolling down inclined plane. From that we have calculated this formula. Putting in the values, what we get? 4 over 3 into 9.8 into 10. The value of H is 10. The value of G is 9.8. We get velocity is equal to 11.4 meter per second. That is our answer, and that is the required answer as well. Moving on towards the next question. A motor car is traveling at the speed of 30 meter per second if the wheel has a diameter of 1.5 meters. Find its angular speed in radian per second and revolution per second. Now, here we have a motor car. Let's draw a motor car over here. Let's draw its windows. And here it is moving in this direction, let's say, with the speed of 30 meter per second. And the tires have a diameter of 1.5. That means wheel has a diameter, sorry, this part has a diameter of 1.5. We have to find its angular velocity in radian, and if it takes a turn, we have to find its angular velocity in the form of radian per second, as well as revolution per second. So let us calculate this one now. We have the data with us. The velocity is given to us, which is 30 meter per second. The diameter is given to us, which is 15 meter. Now, in the next case, we can convert the diameter to radius by dividing it by 2. So 1.5 divided by 2, it is going to be 0.75. So we have to calculate two things now. The angular velocity in the form of radian per second, and the second one is angular velocity in the form of revolution per second. Solution. We know the formula that linear velocity is equal to r into angular velocity omega. Omega will be equal to v over r. We have the value of v, we have the value of r. So omega, which is given to us, which will be 30 divided by 0.75, or we can say omega is equal to 4 radian per second. So one answer we have already calculated, that is 4 radian per second. Now for the revolutions part, how many revolutions were there in seconds? For that, we are now dividing it by 2 pi. So 40 divided by 2 pi, we get revolution per second, and that is our answer, which is 6.37 revolution per second, and that is our required answer as well. Okay, we have done all the numericals in this chapter. Alhamdulillah. Inshallah, we'll meet again. I hope you enjoyed today's lecture. Allah.